equal to 4. And that's gonna, the whole thing's gonna be an asymptote, like an oblique asymptote. So that corresponds to C. And this has to not equal 0, otherwise it's going to be like undefined. So we need to find one cos equals to 0. And you can trial and error everything. So this is definitely not going to be it. It's going to be repeating. But you can trial and error it. Like you can put like n equals 0 and n equals 1. And you should get like 0 on the bottom. And that's what I did. And I got like n values as like the ending, like pi by 4. And if you put this into here, you get like pi by 2, which is 0. So then it should be D. This one, I to the power of 1 is just I to the power of 2 is just -1, I to the power of 3 factorial is just going to be, no, -1. No, wait, yeah, should be -1. And then -1 again. And then from I to the power of 4 factorial to I to the power of 100 factorial, this equals to 97. So then if you do I -1 plus 97, that equals to -I, which is equal to C. Question 5. So that this and arc of this intersects the plane. Find B. Oh, you can find like the separate functions. So like this is tan. So y over x minus 2 equals tan of pi by 4. This is equal to 1. So then you can just y equals x minus 2. And this one, y minus 1 over x minus 5 equals 10 5 pi by 6, which is equal to 10 for -1 over root 3. And then you can just find when they intersect, and that should equal to. Be that. You can just use the cas and find when y and this function equals each other. And find the y coordinate. Question number 6. Use the rule where you times it. When it's like to the power, you just times it. So by 2. And when it's dividing, you minus it. So 4 is equal to 3 pi by 2. And because there's like a restriction on arguments, there's not going to be this option here. So you need to make it within that domain, which is this equals to this, which is A. 7 is x equals to this, y equals to this, from 0 to pi. So from 0 to pi, we find the mod. So diff it it's like this formula. dy dx dy dt plus dx dt squared root and a to b. It's like this formula, dt. So you diff this and put into here. and then plus -4 sine t squared dt, and using the cos squared, sine squared equals 1. Should get let me just this out. You should get which is option B. Yep. Question number 8. So this is the most difficult, like this is like causing a problem. So you let u equals 2x plus 1. So then du dx equals 2. So then you just flip it. So then that's going to be half. So whichever option has half is going to be the answer. So you can cancel like this, all of this. And you already know that this is going to change because it's in accordance with u, not with x. So you can just cancel this out, and then you're just going to be left with e. Question number 9. This one I use CAS as well, but you can like approximate values, like you can sub in values looking by the graph. So like if you look at let's say 0, 0, you'll find that the gradient's like 1. So when you sub in 0, 0 into here, you should get 1. And the only way you're gonna get 1 is if it's like cos, because sine of 0 is just 0. So, and that's gonna be undefined. So, and that could work. Can't get that. And you can try another point, like if you wanted to do at pi by 2 and pi, you should get pi by 2 pi 0. The gradient at pi by 2 and pi is 0. So the only option that would fit for that is B. Oh, this one, sand is added at a rate. So this is dv dt. And when the height is this, on the rate of dh dt equals dh dv times dv dt. Yes. Yeah. So then dv dt divided by dv dh. And we need to find these values. So like this is here. So we can just sub that in here. But we don't know this one. We need to use this diagram here. This is R. So 1060 equals R over H. And we know the volume for this is pi r squared H, but since there's like 2 independent variables, we need to make it into 1. So then H R equals root 3H. Sub that into here. And sub the value of H, which is 0.5. And you should get something like 1.5 divided by 3 pi 0.5 squared, which is approximately like 0.64. You see. Let M be that. So you just do B, A plus B over 2. Not A plus B, I mean like this plus this over 2 equals to -5. Oh, I'll just work this out. a negative 3 over 2, like the midpoint formula. And you do it for all of them. So 1 plus b over 2 equals 3 over 2. And then negative 2, negative 1 over 2 equals c. So then you should get a equals negative 7. B times 2 equals 2. C equals negative 3 over 2. So I think you should get E. Oh, this one took a long time. So you can use a CAS for this as well. And I think you should use a CAS because it's going to take a long time. And you find the resolute. So oops. AWB hat. And you should get, I just use the CAS for this. I like put these values in. And then you should get like squared m this plus n this plus pk this, and you should get a final value of, and all this should like equal to this when you simplify it. Which is 2, negative 3, and 1. So for this one, f1 equals 2 in the j component. So j I f1 equals to this, and there's an acceleration of this. So then 2j so then f2 should equal 3 root 3 I this. So then you do the dot product of f1, f2, and that's gonna equal to which is equal to 2, and then you just solve for theta, and then theta should equal to cos inverse. Which is this one, yep. So the tension is gonna equal when it's released 1 and 2. So the total mass for the whole system and the net force is gonna be this pulling it down, which is 3g. So then F net equals 3g. So 7a equals 3g. And then acceleration equals 3g over 7. So if we're looking from there, we do g minus t equals, this is the acceleration, 3g over 7. So then t equals 4g over 7. A. 15. At t0, the force causing it to accelerate. So this is in the j component. So it's going like this. And it's going to continue going this way, but it's going to go this way. And the only one that follows that pathway is like looks like a parabola, which is E. This one, the acceleration of particle can be expressed as V equals this. When you find the acceleration from here, which is V equals V dV dx, so then you just find V is already given here. dV dx is just going to be x cos x plus ex sine x, and then you just times this here by this, and when you simplify it, you'll like use the it's gonna be like this. This comes from like the angle formulas. It's like 2 sine 2x. You just divide it by 2. There's no 2 here, so that's just 1. So you just divide it by 2, and you should get that. And this is where you get this from. 2x, not x, which is A, I think. F1, F2, F3. If B equals 2A. So B equals 2A. F1 sine A equals F2 over sine B. F1 this goes up here, this goes down here, this goes up there, so then F1 over F2 sine A over sine B, and you use that formula up here, this formula for this, because that's sine, because B equals to A, sine A equals 2 sine A cos A, cancel this, so then that's 1 over 2, 1 over cos is sec A, which is E. This one you can use CAS for, and it's pretty simple. You just go into stat. I think it's like norm, something norm, and then you just plug in these numbers. But if you wanted to do it like by hand, first you need to find which is equal to and then you just do mean plus or minus this standard deviation, and the standard deviation is 4 over root 36. So then you do 65 plus or minus 2.32635 times 4 over root 36. And you should get 63.4 and 66.6. Yep. So for this one, mean of 8, variance of 19, mean of 4. So you put the means together. So you should get 4a plus 4b equals 8, because e of ax equals ae of x. So you just times it. So you just put 4. And the variance is going to be a squared varx, b squared vary, and that should equal to 90. The mean and the variance are the same for x and y, so that's why I use both the same. So you should get 9a squared plus 9b squared equals 90. So then you can use the simultaneous equations in your CAS, and a equals 3, b equals -1, or you could get a equals -1 and then b equals 3, but the only option here is C. Yep. 20 0 to 100. So the standard deviation is 0.2887 root of n, which is 100, which is approximately 0.03. Again, you can use a CAS for this. Pretty sure it's on statistics, something norm again. Don't remember, but it's this one was like interval. I'm pretty sure interval something. This one is like t-test or something's test on the CAS, and if you put the if you search that, and then you will find, and you just plug in the values. But you can do it normally as well. Which is equal to 0.1704. So for this one, sec tan squared plus 1 equals sec squared. So sec x minus 1 and then y equals 10. T square this, this squared, so 10 squared plus 1. So y squared plus 1 equals x -1 squared. And then if you solve for this and then find the root, like y equals, you should get equals x squared -2x. And you should get like plus or minus, but if you look at the domain, it's going to be plus because it's positive. So for the domain, you can either plot this graph using your CAS, or you can just look in here. This has to be greater than 0 under the root. So then you should get, you should get x squared has to be greater than 0, greater or equal to x equals 2. So then, and then if you like plug this 2 back in, you should get 0. So then the then you should get 0 as a range. It's gonna be the same thing, the same thing as this, but like when you plug it in, you should get 0. dy dx. So you can use the chain rule for this. Y dt times dt over dx. So that equals to dy over dt divided by dx over dt, yeah. And we know that dx dt equals 2 sine t, 6 square t. And we know that dy dt equals 6 square t. So then if you plug this into here, you should get 1 over sine t. Find the limiting as it approaches pi by 2. You just put in pi by 2 into here, and sine of pi by 2 is just 1. 1 over 1 is just 1. So dy dx sketch the curve of this from x equals to 2. So if you plot this on the CAS, you should get something along the lines of 4 is 2 root 2. So 4 is around there. And it should be like curved a little bit. In the CAS, it kind of looks like straight, but it should be curved because there's like a root in there. So you could tell by the function. It's gonna be like that, something like that. Find the proportion is that d. Okay, definitely in terms of p. So the general formula, it's like pi 0, no, not 0, a to b x squared dx. Yes. So then if you use that from, like, if you use this here, you should get from 0 to 2 root 2 pi sec t plus 1 squared dy. And since we want it in terms of dt, we've got to make it in terms of, so like 0 to 10 inverse 2 root 2 pi sec t plus 1 squared sec t dt. We do this by like using like the chain, kind of like the chain rule, like dy dt times dt. So we dy dt is like here. Where is it? 6 squared, I'm pretty sure. Yep, 6 squared. And then you just put that in, and you should get this answer. So this one, you can use the quadratic, because this is a quadratic equation. So you can just, pretty sure you can skip it, because you can skip like the general formula and just sub it in, because this is like 1 mark. So -4 plus or minus root 16 minus 40 over 4, which is -4 plus or minus 2 root 6i over 4, which is equal to -1 plus or minus root 6 over 2i. So if you plot this, so we plot the solutions of this. It's going to be difficult, like if you don't know, if you don't have a CAS or something, but it should be approximately -1, and then around here, I think, around here, these two values, yeah. Just use the cas, like, to find the value. M and N. The minimum radius is this as the solution. So you can tell that we're trying to get this circle to be like on these 2 points, and the closest you can get is like making it like just right there, just in between those two. And to move that, we move it by 1. So we move it by 1. So the translation is just going to be m equals 1. And then n is basically these, like, going from up to down. So n equals root 6 over 2. I think, yeah, it's here. The radius, yep. The Cartesian, you can just look at it. It's just going to be x minus 1 squared plus y squared equals 3 over 2. And sketch these points, intercepts. And it should look like something like this. Next part, C. Oh, okay. So now they aren't going to give you the thing. So you still use the same approach. So you find the quadratic of this. -1 z. Negative z equals -1 plus or minus root 2 minus d 2. So then z plus 1 has to be smaller than root 6 over 2. So then we know z is equal to this. So then root 2 minus d over 2 has to be greater or smaller than root 3 over 2. And this can be plus or minus. So that's how you get the two values. Whoops. To there. So then you'll get 2 minus d plus that. So then if you put this in your CAS, it can do it for you. You should get d 1 to 5. -1 to 5. Oops. So this one, they don't give you anything, like the zero values, just A, B, C. Again, it's just the same approach. So Z. It's going to minus 4AC over 2A. Then Z plus 2, no, B over 2A equals plus or minus root B squared minus 4AC over 2A. So then Z plus B over 2A equals mod of this minus 4AC over 2A. So then you should get P is equal to B over 2A. And then Q is equal to root B squared minus 4AC over 2A. Okay, this one. So dP, so we need to get it like dP here and like dt here. So we flip it. And then we do p dp, and then you should get ln p plus c, and then you just sub in the values of, you can tell by looking at this like what you're supposed to get, and yep, plus c, and then you should get another one, kb. So then if you minus it, the c's cancel out, and log here log e r minus log e of s. So then you can take out the k, and then this simplifies to this. So you can just put in one step, a minus b log e r over s. Yep. Specify the conditions. So the conditions for this, a minus b has to be greater than 0, because you can't have an undefined, and then r over s has to be greater than 1, because in here you can't have 0, like log of 0 doesn't exist, so it has to be greater than 1. So then you should get a is bigger than b and r is bigger than s. Yes. And then, yep, for k to be bigger than 0, has to be a positive number. Yep. Express this. So again, you do the same thing. So dq, this is equal to dt, et times e to the power e negative q, and then you separate it. So you should get, this is the same thing as this, e to q. You separate it, bring this up here, bring this here, and then that should equal to integration of et dt. Show that q is that. So eq is equal to et plus c, as q equals to 1, t equals to 0. So q equals to 1, t equals to 0. So therefore c equals e minus 1. So then if you sub that back into here, you should get q is equal to log e et plus e minus 1. Show that the graph does not have a point of inflection. If it doesn't have a point of inflection, then f double dash of t cannot equal to 0. So if you use the cas again to find the double derivatives of dq over dt, e to the power t e negative 1, whoops, e to the power t e negative 1 over et plus e negative 1 squared. And you might think that we have like, this doesn't equal 0, but if you do e to the power of t equals 0, then you'll get like log of 0, which does not exist. So Okay, 4a. So we do A, B, C, D. Drawing a diagram just helps me picture it. And so we do A to B, which is gonna be 2, -1, -2. And then D to C gonna be A -4 plus B -3 plus C and 1 plus C. Okay. So then you just equate those. So A -4 equals 2. B -3 equals -1. 1 plus C equals -2. So then A equals 6. B equals 2. C equals -3. So this one, AB we know is, you can use the CAS as well for this again. You don't really need to solve it by hand. 2, -1, 2. And then we need to find AD. AD is equal to 2, 4, -4. So then let this equals to A, let this equal to B. So A dot B over A B cos of theta. And if you sub these points in, like this and this, using the CAS here, you should get cos theta equals to 4/9. Find the area of the base of the pyramid. So to find the area of this, we do the height of equal to AB. Sine of this angle, which is equal to √65/3. So then the area is equal to height times the length, so AD, which is equal to √65/3 times 6 equals 2 √65. Show that this is perpendicular. A times A dot B equals 0. That's just the basic rule. So 6. AD equals 0. So you just find the unit vector of this, which is just going to be 1/√65 6i. Find the volume of the pyramid. So the volume of pyramid, it's going to be the height when the V equals 1/3. The area times the height. We already found the area of the base. So to find the height, we do the unit vector times, so the unit vector we found here, times BP, which is equal to 36 over root 65. So then 1/3 times 36 over root 65 times 2 root 65 equals 24 units cubed. Question 5. The mass of this is initially held at rest near that. So it's on a smooth plane, no friction. This is going down. This is going up. So then normal force is here. This is a weight force. Tension is there. Weight force 2. Tension here going up. If the system is in equilibrium, so F net equals 0, so then M1 G sine theta equals M2 G. So then sine theta equals M2 over M1. So the angle has to be smaller than pi by 2, greater than 0. So then M1 G sine theta through G. So then theta smaller than sine inverse. So part 2CI, so the mass of the first mass, G sine theta, has to be smaller than M2 G. So then acceleration M1 plus M2 or the maximum in meters that it would move up the plane. So it's going to be like this. So once it hits the ground, there's not going to be tension. There's not going to be tension on here, like pulling this towards here. Like once it pulls down like 2 meters, this is going to go 2 meters. And then once it's like here, past here, there's not going to be any tension. It's going to keep moving because it's going to have momentum. So initial is 0. And we know the acceleration is from here. So we know that M1 equals to M2. And if we sub that into here, we should get A is equal to G over 6. And we know, like, when it falls down, this is going to go up 2 meters. So the distance equals 2. So then, using SUVAT, u equals 0, so v equals 2 times g over 6 times 2g over 3. Now, that's the acceleration like up to here. Now there's not going to be any tension, so, and it's going to like stop when v equals 0, so like its final position is going to be like 0, so it's not going to travel anywhere. So then we use the same formula, so just 0 equals u squared plus 2as, which is equal to 3 minus 2 times g over 4s. So then s equals to 4 over 3, and then you just plus the 2. Like, this is going to travel up to here, and then it's going to stop somewhere up to here. So then it's going to travel the 2 meters plus this 4 over 3. So 2 over 4 plus 3 equals 10 over 3 meters. The mean mass between 370 and 375, the mean is here. This is here. N equals that for each random packet. So we know the standard deviation is 15 over root 50, which is 3 over root 2. And then we need to find probability of which is 0.497. And we need to find probability of at least 1. So we can do 1 minus none, which is 1 minus 0.4907 squared, which is equal to 0.741. So means of the two differ by less than 2. So mean 1 minus mean 2 has to be less than 2. So this 2. So then of the two random samples, they have the same mean. So the mean of like E1 is just going to be 0. So we'll just, yep. The standard deviation is root of here, this. You just plus them, but like you have to square it because it's like you can only plus it using VAR. You can't plus standard deviation by itself. Which is equal to 3. So then using the CAS, and you put standard deviation as this and mean as this. Probability of -2 0.495. Fine. Oh, okay, so this is a two-tailed test, so it's not going to equal. So mean is equal to 375. Mean. No, mean. H1. No, H0. H1 is alternative. This is the one they predicted. This is the population. They're trying to test this if this is true or not. Does not equal 375. Find the P. Okay, this one you just use CAS. Like, I'm pretty sure it's. And then you just plug in this, and this. And then you should get which is equal to 0.046. Does the mean of this 5, so since p is smaller than 0.05, we reject the hypothesis. The machine is not working properly. So the smallest value of a sample of 100 packs of this, so A, it has to be smaller. You can just use CAS and solve for this. And yep. 6 exam 2.
Thank you.